Hello everyone, it's great to be here today. Our next talk is about the API secrets sprawl. So basically it's the result of a research that we conducted in our research team at Escape about how can we get for API secret tokens if we scan 1 million websites on the internet. So in this talk, we will cover why first we started this research of looking for API secrets in the wild, how we detected hard-coded secrets in front-end code. So there is an analysis of the technical process that we created for detecting hard-coded secrets, what critical findings we found, and including millions of dollars in tokens, and we'll come back to that later. And finally, we will cover the recommendations that we can use and leverage to reduce the risk of leaking secret tokens in front-end code. Before we start, I'm Tristan. I'm the co-founder and CEO of Escape, and I'm a graduate from UC Berkeley, an ex-researcher in AA applied to cybersecurity. I got hacked myself, so I started a cybersecurity company. And today I'm here with my co-founder Antoine, who is the CTO of Escape. He's a passionate open source contributor, creator of GraphQL Armor, and he's a huge Apple fan. He worked at Apple in cybersecurity. If you didn't get it from my accent already, we flew from Paris to here, so we are both French, and we work half in the US, half in France currently. So just to give you a bit of a word about Escape, Escape is the API security platform. So basically, we have an agentless approach to discover and help you secure all your APIs efficiently. We connect to the tools that you already use, so by agentless scanning, cloud providers, API gateways, developer tool, and we use this to perform automated API discovery, protect your APIs at runtime, and run automated security in the CI/CD through API DevSecOps, and then we export all the results in the tools that you already use. Okay, so we have a research team at Escape that focuses, there is no screen anymore, okay. We have a research team at Escape that focuses on doing researching API security of all sorts. So we created last year a report, the state of GraphQL security, where we analyzed more than 1,500 public GraphQL APIs and found more than 40,000 security results. And then we published a second research report, the state of public APIs, which analyzed more than 6,000 public APIs for security vulnerability. And we explain what we found and what that says about the state of API security. And the topic of today is another report that we recently published, which is the state of API security, the API secret sprawl. So you can download this report using this QR code. It contains all the results that we're going to present in this talk, but more in details and with graphs and explanations and analysis of the findings. Okay, so first, why is an API secret leak a problem? Why should we not leak secrets, obviously? So every company now has resources on the web, and the DevOps team struggle to deploy assets effectively and securely. So you have like automated deployments of websites. So how can we do that securely? So there are many examples of breaches that come from exposed API and exposed secrets on the internet that can be easily exploited without advanced knowledge to fetch sensitive data or to gain access to systems. If we analyze what we have to secure our applications and API, we have like many different techniques and tools. So we can start with threat modeling in the design phase. We can do software component analysis in the development phase, static analysis and code analysis, dynamic application security testing, and then runtime protection. So we have many different tools and many different processes to create more secure applications. But what about secrets? So for secrets, we have a few tools like Git Guardian, Git Leaks, or SemGreps that can help find secrets in Git repositories. We have API gateways and dynamic testing tools like Escape that can find secrets in APIs when they're deployed. But what about front-end that could be embedded in publicly accessible front-end code like JavaScript. What happens if my developer embed front-end secrets in the front-end code? So this is the question that we ask ourselves, and this is why we decided to do this research. And I will let my co-founder and CTO, Antoine, explain to you how technically we conducted this research.
Thank you very much, Tristan. So here, the CTO on stage. So this part is going to be a bit technical, and we felt like this was very important that everyone gets the full pictures that explains why it's really hard to find tokens currently today in frontends. So before doing too complicated things, I wanted to know who in the audience is familiar with front-end development by raising hands. Okay, so it's roughly 15–20% of the audience. So let's get one step back so that you can understand a little bit how front-end development works, and this will explain you why finding secrets in front-end is still a challenge today. So basically, front-end development and front-end consists in static files, so basically HTML, CSS, and JavaScript. So normally you are all aware of those static files. Those files, they are downloaded by your browser when you're browsing the web, all right? And they are used by your browser to render web pages. The problem is that in modern application development, those static files are not pretty convenient to build modern applications and very, very dynamic applications that are compatible with your mobile and so on. That's why front-end developers, they chose to use and they created frameworks for front-end developments. So here you have the three main frameworks, which are React, Vue.js, and AngularJS. And those frameworks basically consist in creating very complex front-end applications for modern web by building small modules with complex dependencies. Okay. The thing is that your browser is still not able to read this front-end, this framework code, and that's why you use what is called bundlers, when Webpack is one of the most famous bundlers used today on the market. And those bundlers, they are used to transform, to convert those this framework code. Sorry, my mic is not working anymore. Thank you, Tristan. So those bundlers, they are used to transform your framework code into static files that are understandable by your browser. Okay, so this is basically the output of the bundlers, especially for the JavaScript files that we saw earlier. And this is really important. We choose to focus on JavaScript files because in JavaScript files, you have the business logic of the app, which is coded, the algorithmical part. And then this is in JavaScript files that we are the most likely, that it is the most likely to find actually secret tokens leaking from APIs. Okay, so how do we do that? The first thing that is important to understand is that there are two kinds of tokens. We can split tokens in two categories, API tokens in two categories. The documented tokens, so those are tokens that are used in many web applications on the web, and they are publicly documented. For example, if you use OpenAI API, Stripe API, and so on, you use documented tokens. In that case, finding them on front ends, it's actually pretty easy. You just use pattern matching and the Google.regex does the job. Just a few words on those documented tokens. There are a lot of tokens that are actually just public keys, such as Google Maps keys, for example. We didn't care, we filtered out those keys into this research because they are not relevant for the research, and they are not leading to sensitive data and so on. For example, Google Map public key is just public, but it's still a token. Same for Amazon S3. It's more that those tokens, they are not public, but they're very scoped. They have very low privilege. So we also filtered that kind of the report. So every result we're going to present you afterwards does not include those results. That was an important note. All right. So, but what about the undocumented tokens? The tokens that are built by your developers in your companies to create applications and to connect to their internal APIs, and that are not actually public to the internet, but that are giving access to your application, by the application that developed internally. The classic way of doing that is to use entropy. So for example, before Tristan talked about static analysis tool. The static analysis tool, they are able to find strings in well-structured code that are complex with a lot of random characters and so on. And those strings, hence, they are very likely to be API tokens. The thing is that, as we just saw earlier, in the JavaScript bundles, there is already a lot of entropy by design. So this is what we just saw earlier. So using the entropy strategy only cannot work. It will lead to tons of false positives because every single of the character here could be considered actually as a token. So this is a bad strategy. Especially, we are not authorized to test the tokens, and we will take a lot of time to test all the potentially extracted strings with entropy to see if they are real tokens and so on. But obviously in the study, we only want to focus on the real tokens, on the real positives, on the true positives. And this is where comes the algorithmics tour de force. We managed to leverage abstract syntax tree to extract those tokens with a high confidence signal. So a few words about AST. I won't deep dive into the detail here because it's pretty complex, but the thing is that what you need to understand here is that we restructured the code, okay, to understand the context where the variables are used, declared, and for example, something very basic is that we are able to identify the context where there are API calls in the JavaScript bundle files. And in those specific contexts, if they are high entropy variables, they are very likely to be API tokens. And actually, this strategy was a huge success. So the cool thing is that this strategy is also very cost effective. In terms of computing power, it requires almost nothing. So I won't dive into this architecture, but what really matters is that we inputted 1 million domain names into this algorithm, into this architecture. We filtered out the sensitive domain names, such as the government domain name and so on. I saw the FBI was giving a talk in the other conference. We don't want to be in trouble with them. We managed, so this leads to stripping almost 50,000 domains. That's why there is not 1 million domains. So I forgot to mention we took the top 1 million domains. We managed to scan 4 domains per second and all the subdomains associated, so this is pretty fast and cost effective, for a total time of computation of 70 hours approximately. And in total, we managed to parse front ends of almost 200 million front ends and JavaScript pages. So this is quite huge for only 70 hours of computation. And what is really fun is that all of this only cost us $100. And as Tristan is going to present you now, this investment, but the most profitable investment we've ever made, I think.
Thank you, Antoine. So Antoine explained how we managed to scan all those websites and how we managed to strip false positives, secrets, to focus on what really matters. Now let's take a look at the results and especially how we traded $100 of computation power for $20 million. In total, we found almost 19,000 secrets overall in all those websites, so that's a lot of leaking secrets on the internet. If we take a look, there are a lot of private, can you go,
Sorry.
please? Yeah. If we take a look, there are a lot of private API keys, GitHub access tokens and GitLab access tokens, so the developers are leaking their access tokens on the internet in their front-end code. You might notice there is a bit of OpenAI API keys here that are leaking also in front-end code. And on the top, you can see there are like Twitch tokens, Discord, but also Stripe tokens that accounted for almost 1% of the found secrets, which is frightening, to be honest. Okay, if we take a look at like the domains that were leaking the tokens, we can see that obviously almost half of the results came from .com domains. And interestingly, the country that is leaking the most tokens is Brazil. So yeah, they got the first place. And also in the EU, it's the Netherlands that are leaking the most tokens in their website. So interestingly, we can make a comparison of the maturity of security processes in different countries. When it comes to the industry, really all industries are represented. Of course, media are very represented. Gaming, aerospace, online dating, tech. So many industries are represented in the leaking tokens. And what's interesting is that the biggest number of secrets exposed in a domain is 28. So there is a website that is almost leaking 30 secrets. But also, the average exposed secrets per vulnerable domain is 1.7, which means if you leak one secret, you are way more likely to leak others, because it probably means that you don't have like the best practices implemented to avoid this from happening. So there is a correlation. When you fail once, generally, you have other tokens leaking. Okay. If we take a look at how they are leaking, we can see that front-end development best practices are still prevalent. So this is a nice example of a developer calling the OpenAI API from the front-end with including their private OpenAI key in their front-end code for everyone to see. So obviously you should do that on the server and then have your API communicating back the results on the front-end code. And this is an example of something that can leak your token very easily. But this is not the most complicated, and this is something that is already known. So if you implement the best practices, you should probably not have that. However, there is something that we noticed that is very common, even in organizations that have implemented secret scanning in the repositories. Because today, as Antoine explained, there is like a webpacker, like a bundler, like Webpack, that use your developer's code and bundles it in HTML, JavaScript, and CSS. This happens in the build time, generally in the CI/CD, and this bundler has access to the environment variables of your CI/CD. And what happens, and we noticed that sometimes this bundler is not well configured, there is a misconfiguration, and it actually packages the .env files directly inside of the front-end code. So we have found many front-end bundles with just the .env file that is like just bundled with the JavaScript. And sometimes the .env files contains only like private information about the CI/CD, private CI/CD tokens or services tokens, but sometimes it also, if you are in a monorepo context, contains the environment variables of the backend code. So this is really a huge problem, and we noticed it a lot of times in this study. So overall, over all the secrets that we found, about a third could lead to an entire business shutdown. So very critical secrets that could be exploited to create huge consequences on the companies that were affected. We found, for instance, hard-coded RSA private keys, which you don't want to do that, and especially millions of dollars in exposed Stripe tokens. So for instance, we found one single token that was hard-coded in a front-end JavaScript code, and that could lead to $17 million of money in the Stripe account. And it was a private Stripe token that was directly exposed on the front-end code. So now, how do we avoid that happening to us? So what mitigation strategies can we put in place to avoid this from happening to our companies? And I will give back my mic to Antoine.
I think it's
okay,
working.
Perfect.
Again. Thank you very much, Tristan. So now, just a very basic recommendations about how to avoid those kind of leaks and to avoid to lose millions of dollars in your company for just stupid tokens left in the front ends. Okay, so as Tristan said, the first thing, of course, it's very basic, but the thing is that developers are pretty lazy, okay? Especially front-end developers, they are making API calls directly without talking to the back-end developers. And especially here we take the example of OpenAI, so this is a huge trend at the moment. The front-end developers, they want to integrate chatbots and so on directly in their front ends. And they are just leaking the organization OpenAI token. So whereas the good practice, obviously, is to use the backend code, because the backend code, contrary to the front-end code, cannot be accessed by the customers, by the browser. Only the browser only downloads the front-end code, so this is obviously the right way to perform the action. It requires a little bit more synchronization and latency in the development, but like this is the very basic of security. Okay, the other thing is to leverage actually type prefixes. So we talked earlier about documented secrets. What is really cool is that internally, instead of generating random strings, you also type your internal tokens, your private tokens, your homemade tokens, that you type them as if they were public, okay? So you leverage type prefixes. You have libraries to do that in every languages. So this type ID is for Go, I guess. And this allows you to make the static analyzers work properly inside your repositories. What I mean is that if you consider that your tokens should be properly documented and typed, even the tokens that are developed internally, you can just implement the regexes inside your static analyzers, for example, SemGrep, and hence they won't be able to leak on the internet because they will be easy to identify in the code soup we saw earlier, even in the bundled JavaScript. So for example, Stripe is doing that really well, and all of their tokens, they are prefixed according to the usage of the token. Okay. Obviously, instead of storing the tokens inside the environment files, so environment files are fine for plenty of usage, but not for storing secrets, all right? So here you can leverage vaults as a service, such as AWS Secret Manager, HashiCorp Vault, or in GitLab and GitHub, you can also store your tokens properly. And obviously, those tokens, since they are not in environment files, they won't be bundled by Webpack into your front-end applications. Again, something that is really simple, but you should use scoped tokens, which means tokens that are only giving access to what your user needs, okay? Not too broad access tokens. And you should also use tokens that are expiring, because a leaking token that is expiring is still better than a token that has an infinite expiration time. For this, you have tools such as Vault Key Rotation, Vault Dynamic Secrets that can help you implementing this process at scale in your company. Okay, so thank you very much for listening to us. If you want to see the full report and download the full report as PDF, feel free. Also, we really invite you to ask us questions during the conference or even after by adding us on LinkedIn. We will be happy to answer you, especially if you want the slides. We can show you the slides with you on LinkedIn. Thank you very much. Yes?
So you talked about that there were some critical findings like which could lead to a business shutdown. You showed us an RSA key. Is it possible to use any of those to, as an initial access point, or initial access point to the organization?
Yes, so this is exactly what we meant. So basically the most critical findings were three things mainly. So RSA keys that could give access to like the company servers, code repositories tokens like GitHub, GitLab, or CI/CD tokens, where you could actually like get into the code repository, change the code, change the deployment, like attack the supply chain. And the last one was like everything that is related to Stripe or to money, basically, where efficiently you could steal like $17 million from someone using their leaking tokens.
Thank you.
Yeah.
So you had a slide with your infrastructure for the scanning. Is there a deep dive you guys have somewhere on more of that infrastructure?
It's in the report. It's a bit more detailed, but basically just very simple Kubernetes scaling. We just have pods that are running in parallel. There is nothing crazy in that architecture, but for sure you can see more details in the report, or we can discuss that directly on LinkedIn if you wish. Feel free to contact me.
Cool. Thanks.
One last thing that is worth mentioning, we have implemented this detection strategy in Escape itself. And Escape has a free tier, so you can just go on the escape.tech website, log in, and plug in your domain, and we'll tell you if this applies to you.
Is there a way to monitor or do this same exact thing on Onion sites?
In internal websites?
Oh no, .onion website, like the dark.
Oh, I don't know. Like on the Tor website, we could try.
Yeah, we could try. We didn't do that. We just used public domains, but it would work the same with Tor. It's just that you would have to install Tor in the middle of the traffic, but there is no difference. You just iterate through the domains, and you do it. But we didn't do that in the study. Maybe for the next study.
Maybe.
No, we have a lot of research incoming with more cool reports that will be published soon. Okay, any other questions?
Time for food.
I'm sorry,
Can you speak louder, please? Sorry.
So you mentioned you filtered out pre-signed.
Oh yeah.
How did you do it?
Yeah, because they are documented. They already exist. So since they are known, the pattern is known. We just filter them out. That's all.
Yeah.
Is the research only done on front end and not on application, like application APIs? Is it only on front end?
And this is another study. But yeah, here it's only for the front ends. But you can find maybe we have the state of APIs, which includes part with the secrets. Yeah.
There is another reporting coming in like 1 month and a half about that. We are currently working on it. So.
Thank you. Okay, I thought you had a question. Thank you very much.
Yeah, thank you very much.
Enjoy your meal.